This is a demo that I like to do to show how diseases can be spread. Any kind of harmful microorganism that can spread disease, we call it a pathogen. And the kids, I usually start out asking the kids if they recall a person by the name of Typhoid Mary in early American history. Her name was actually Mary Malone, and she has actually been identified as the first person in the United States to be a healthy carrier of a pathogenic organism associated with typhoid fever. She immigrated to the United States back in the late 1800s, and she worked as a cook in New York City. And during that time, she is presumed to have infected 53 people, 3 of whom had died over the course of her career as a cook. And even though she was forced to be quarantined 2 times during her life, she still had this impact. So what I like to do is just kind of give you a little bit of a demo. I have 4 cups up here of a clear liquid, and one of them is infected. Now, I don't usually use 4 cups. I usually have 14 cups for 28 students, so 1 cup per team. You would have to adjust the numbers depending on how many kids, but I have 4 today for this demonstration purpose. One of the cups has diluted vinegar in it. The other 3 cups have water. Students don't know this. All they see is a clear liquid. I tell them don't touch, don't put your finger in it, don't drink it, don't smell it. And so what I have them do is a series of exchanges. And in order to do an exchange, what they do is, if I were the team and I had cup A and I wanted to go to cup C, I would do an exchange. That would mean pouring all of the contents of 1 cup into the other, swirling it, and pouring back half. Normally with 28 students, they would do 3 exchanges with contact with 3 other teams. So they don't know. I have them marked as A, B, C, and D, and they don't know what's going to happen here, but I know ahead of time that B is my cup with vinegar. So let's kind of simulate that. Let's pretend that B does an exchange with team D. You pour all the contents in and swirl it around gently, trying not to spill it. Pour back half. Okay? I have a table for them to record it. Team D does an exchange with Team C. They pour all the contents in, swirl a little bit gently, pour back half. For today's demonstration, we're going to have just those exchanges, and that's it. Now I come along with the magic liquid, and it turns out that as I put a couple drops of this liquid into the cup, if it turns green, they're not infected. Woohoo! If they turn red, danger, danger, they are infected. So let's see what happens here with our results. I already told you that B was the cup. Okay, so we drop in a couple drops there. Green, not infected. A couple drops into red, or into the B cup, it's infected. Uh-oh. A couple drops into the C cup, infected. A couple drops of this universal pH indicator into the D cup, infected. Because remember, I started with B, I exchanged with the cups, and they exchanged with each other. Only A did not have the exchange. Technically what this is a pH indicator, and if something is a base, it'll be green. And water is more basic than acidic. It's more of a neutral substance. What I had with vinegar, vinegar is actually an acid, and an acid will turn red in the presence of a pH indicator. And then we'll go back to the table to see how this might play out. But the whole purpose is to set up a simulation. I have maybe 14 cups, 2 originally infected. They do a series of 3 exchanges. We test them, and then the students have to backtrack and figure out what were the 2 cups originally infected, aka with the vinegar instead of water. In real life, health officials often have to look at people that have HIV or something else, and they have to decide, you know, who maybe spread it to who, so they can try to stop the disease as soon as possible.